Okay, guys, so let's go through the addition of vectors. So let's say that you have two vectors, made two vectors over here. So let's say that you have two vectors A and B. Let's look at the head to tail rule first, right? So that's sort of the geometric way of adding vectors, where you only use geometry. So let's say you have two vectors like this. Let's say these, you can show it like this. No matter where you take the vector, doesn't change, right? So as long as it is pointing in the same direction. So let's say you have two vectors over here. Now I want to add these two vectors. How would you do that? You will take this guy B, right, and bring it over here, right? On the head, you put the tail of B on the head of A, and then you will join the tail of A with the head of B. So that's your resultant vector A plus B. Okay. Now this stays the same. So in vector addition is associative, like A plus B is equal to B plus A. So instead of that, you can also write this as B, and then you can put the tail of A on the head of B. So that's how you would show B plus A. So A plus B or B plus A, they're the same. And that sort of completes that parallelogram also, right? So there you go. So, okay. This is where we showed them before. So this was your A, this was your B. Okay. So that's the head to tail rule. You can add any number of vectors. So let's change the vectors. So let's say that instead of that you have let's take another example. So instead of that, instead of those vectors, now A and B point in this direction. So this is your A, this is your B. So what you're going to do again is you're going to bring B and put it on the head of A, and then this is your resultant vector. Okay. Oops, I moved to A. Here you go. Right, and this is again true if you do B plus A. So you're going to do B, then you're going to do A. Okay. So that's again true. Okay. So A plus B is again equal to B plus A. Now, what if you want to do A plus A minus B, okay, instead of A plus B? So then for that, A minus B, you will flip the direction of B. Okay, so you're gonna flip it. Okay. Now this is your minus B, right? Now if you want to do A minus B, you will take your let's take a clear page. Okay. So then this is your minus B. It points in the. So you make sure for subtraction you flip the vector. So you're gonna I flipped B. This was the original direction of B. I flipped B. Okay. So now you're gonna perform the same steps. You're gonna put the tail of negative B on the head of positive A, and that's where your vector points. So this is your A minus B. But remember, subtraction is not associative. So A minus B is not equal to B minus A, but A minus B is so. But A minus B, of course, is equal to minus B plus A. That's the same thing. You're just writing. This is essentially you still have the same vectors, right? But it's not equal to B minus A. So let's say you want B minus A. For that, I still have B. Okay, my B is still this, but my A, I have to flip A. Okay, so that's my A, right? So now B minus A would be, so this is B and this is A, right? So B minus A would be this vector. So voila, it just points in the opposite direction. Okay, so B minus A, this is your B minus A, right? So you can see that they are the same vector, but they're pointing in the opposite direction. So A minus B is equal to minus of B minus A. Okay, so that's B minus A points in the opposite direction to A minus B. So that's the geometric way. Let's say that you have you can add these as you can use algebra also to add vectors. So let's say you have a vector A, which is A I hat plus B j hat. Okay, So let me just review what these are. These are unit vectors, I hat and j hat. They're called I hat, j hat. They tell you which component you're dealing with. Oops, I'm sorry. Ax and let me write this again. So a equals ax I hat plus ay j hat. Okay, and let's say you have two vectors, b equals bx I hat plus by j hat. So again, these are vectors which tell you which component you're dealing with. So this is the x component, this is the y component of a, this is the y component of b, this is the x component of b. Okay. So if you want to add the vector and find the resultant, then you would do a plus b equals. So now remember, the i's only talk with the i's and the j only talk with the j. So you add the I components, ax plus bx I hat and ay plus by j hat. Okay. So that's that's how you would add. If you have a k component, you would add that also. Okay, but we're just looking at 2D for now. Now let's take an example. Let's work out an example. So let's say you have a vector let's say a has let's look at an example. Okay, so which will sort of include both the head to tail rule and the algebra method also. So you get a equals, let's say a equals 2 I hat. So a just has an x component, it does not have a y component. And let's say b is equal to 2 I hat plus 3 j hat. Okay, so a plus b will be equal to, now you're only going to add the I component with the I, there's no j component. If you want, you can write that like 0 j hat. Okay, so the 2 plus 2 is 4, so you get 4 I hat plus 3 j hat. So that's your resultant component. Let's call that a resultant vector. So that's C. Okay, so C is 4 I hat plus 3 j hat. Now, if you want to plot these vectors, you can also plot these. So let's make a rough sketch of how these vectors look like. So the vector A only has an x component. Okay, so you have so let's call so x a is 2 units in the x, so a 1 2, so that's your a. Okay, so let's draw that as let's draw it like this. This is your a, and your b is 2 in the x, so that's your b is still like 1 2 in the x and 3 in the j, so 1 2 3. So your b is this is the tip of your b, so there you go. So that's your b. Okay, now you can get c also by using the head to tail rule. So if I place this a on the head of b, so a is 2 steps in the x, so you get this will be your a, right? So then c would be when you join the tail of b with the head of a. Okay, so that's your c. Okay, so this is your c. Let's get black. So this vector is your c. This is your a. Okay. Now so you can see that c is 4 in the x, so 1 2 3 4, and 3 in the y. So 4 units in the x and 3 units in the y. So that's your vector c. And so you can use the same process. If you subtract the two vectors, so a minus b would just a minus b would be just ax minus bx I hat and ay minus b. So it would be good exercise to try a minus b, right? So you have to flip the vector and then find the resultant by using the same process. Okay, so this was it for the addition and subtraction. If you have any questions, post them in the comments. Thank you for watching, and please subscribe.